Let us solve the differential equation dy by dx plus x by 1 minus x squared times y equal to x times root y. Now we know that linear differential equation of first order is given by dy by dx plus px times y equal to qx, and we know how to solve it as well. But this is a Bernoulli differential equation which can be reduced to linear form, and in this case we must multiply by y to the power minus half. Let's do it. When we multiply by y to the power minus half, we get y to the power minus half dy by dx plus x by 1 minus x square times y to the power plus half equal to x. So far so good, but still we are not getting of this type, but we will get it if we regard y to the power half equal to z, and we differentiate both sides with respect to x. So we differentiate both sides to get d dx of y to the power half equal to d dx of z. In other words, dz dx equal to, if we differentiate, we need to apply chain rule. So half y to the power half minus 1 and then dy by dx. And so we can write 2 dz dx equal to y to the power minus half dy by dx. That we can substitute here. And when we do so, we obtain 2 dz dx plus x by 1 minus x square z equal to x. Are we getting exact of this type? Still not. We need to divide it by 2, and when we do so, we get dz dx minus x by x square minus 1 times 1 by 2 z equal to x by 2. Now this is a linear differential equation of first order, and we know how to solve it. For solving it, we need to compute integrating factor, that is given by e to the power integral of p dx. And p is this function which is totally dependent on x only. So this is equal to e to the power integral of minus x by x square minus 1 times 2 dx. Now you see that derivative of x square minus 1 is 2x. So this can be written as integral of d of x square minus 1, that's 2x, so minus half, we need to write that as well, so, times x square minus 1 times 2. So this is equal to e to the power minus 1/4 log of x square minus 1. Now we know that powers can be absorbed by the logarithm, and when we do so, we get x square minus 1 to the power minus 1/4. Again, we know that e to the power log of u is simply equal to u, and that gives us x square minus 1 to the power minus 1/4. So we got integrating factor. Now usual method of solving first order linear differential equation is multiply the given equation by integrating factor. Let's multiply it. So x square minus 1 to the power minus 1/4 dz dx minus x times x square minus 1 to the power minus 1/4 by x square minus 1 times half z equal to x by 2 times x square minus 1 to the power minus 1/4. This can be simplified a bit and write x square minus 1 to the power minus 1/4 dz dx minus x times x square minus 1 to the power minus 5 by 4 times half z equal to x by 2 x square minus 1 to the power minus 1/4. The advantage of multiplying by integrating factor is that left hand side just turn out to be derivative of something. In this case, that something is z times x square minus 1 to the power minus 1/4. In fact, it is z times integrating factor. Now how about the right hand side? Now you see that we got derivative, and opposite of derivative is integration. So once we integrate it, then we can write it is x square minus 1 to the power minus 1/4 times x by 2 dx. Now we know that derivative of x square minus 1 is 2x. So this is equal to half of, one more half, x square minus 1 to the power minus 1/4 times d of x square minus 1. Left hand side we copy as it is, x square minus 1 to the power minus 1/4 times z. Now it's quite easy to integrate. We simply write it as, you know that integral of u to the power n du equal to u to the power n plus 1 by n plus 1 plus some constant. So this is equal to x square minus 1 to the power minus 1/4 plus 1 is 3/4 divided by 3/4 plus some constant. We can cancel 4 out, and we can take this expression x square minus 1 to the power minus 1/4 to the right hand side and set at z equal to x square minus 1 to the power 3/4 plus 1/4, that is just 1 by 3 plus constant time x square minus 1 to the power 1/4, and we are done.